multiplying rational expressions is very similar to that of multiplying fractions together. To multiply rational expressions, we form the product of the numerators and the product of the denominators. When we multiply rational expressions, we always want to simplify, and if we can reduce ahead of time by canceling out common factors to the numerator and denominator, it'll make the simplification much easier. Here in the numerator, these would break down into prime factorization of all 2's. We have prime numbers in the denominator, nothing common. So for this example, we'll simply multiply the numerators 8 with all factors of 2, nothing in common with the 3 and 5, multiply the denominator, and we're done with this rational expression multiplication. In this next example, let's form the product of the numerators and the product of the denominators with prime factorization. So 8 breaks down into 3 2's, x squared into 2 x's, and 3 followed by 2 y's for the numerator. In the denominator, prime factorization, we have 3 times 3 for our 9, followed by 3 y's. 4 breaks down into a prime factorization of 2 times 2, followed by 3 x's. Since these are all factors, we can cancel out anytime we have a factor over itself, since that's equal to 1. We have 2 2's in the numerator over 2 2's in the denominator, which cancel out. We have 2 x's in the numerator that will cancel out 2 x's in the denominator, value equal to 1. We have a 3 over 3, which is equal to 1 as well, and a y in the numerator over a y and y in the denominator results in a 1 as well. Neatness definitely counts. If we look, what remains is only the 2 in the numerator, and in the denominator we have a 3, a y, and an x for our simplified rational answer for the product of these two rational expressions. When multiplying a rational expression, as this example is, rather than multiplying a binomial times this trinomial and then dividing it, rather we'll break it into factors first and leave it in the factors to verify that it is in simplified version for the product of these two. So this first rational expression is understood to have a denominator of 1. Multiplying rational expressions, we multiply the numerators together, but instead of writing this trinomial as is, I'll write the equivalent factored form of it. X squared breaks into an x and x, minus 24, one positive, one negative, that add up to be 2 will result in a minus 6 plus 4. The factor of the numerator on this rational expression, I'll put around parentheses to show that it is a factor or a result of multiplying the numerators together. And likewise, the denominator, rather than writing it in its original form, let's factor it. The x squared came from first terms in each binomial being x, factors of 8, both the same sign, both positive, that add up to be 6, would be a 2 and a 4. We now have this in factored form, and to simplify, we'll look for common factors in the numerator and the denominator, which result in a 1. And here we have the binomial of x plus 4 over x plus 4, which is equal to 1. And as I mentioned earlier, instead of multiplying, we're going to leave this multiplication of these rational expressions in factored form so that it is clear that it is in simplified form. Let's look at one other example. Here we have multiplication of two rational expressions. Factor first, 25 minus x squared. We have two terms. Is it a difference of squares? It is. Square root of the first minus square root of the second, square root of the first plus square root of the second. Multiplying that numerator times the numerator of the second rational expression and putting it, rather than in its current form, in factored form is x for the first term, factors of negative 20 that add up to be negative 8, one positive, one negative will be a negative 10 plus 2 for the last two terms. The denominator, the first term came from x in each of the binomials. A negative 35, we want factors that add up to be a negative 2, which will give us a negative 7 and a positive 5. And multiplying that by this denominator, again in factored form, first terms came from x, factors of negative 10 that add up to be negative 3 will be a negative 5 and a positive 2. Now that it's in factored form, we look for those common factors in the numerator and the denominator. And the ones that jump out first for me, I have an x plus 2 over an x plus 2, which would equal 1. Ones that aren't quite as obvious, but with commutative property, 5 plus x is the same as x plus 5, so they will cancel one another out. And then looking a little closer, these two binomials, 5 minus x and x minus 5, are opposites. The 5 is positive in the numerator but negative in the denominator, and likewise we have opposites of this x term, negative in the numerator, positive in the denominator. And we found previously that if we factor out a negative 1 from either one of the binomials, it will change the signs from the opposite of what they are. 5 will become a negative, minus x will become a positive, and if we do the distributive, we're back to what we had. But now looking, I do have a positive x and I do have a minus 5, so those factors will cancel out, leaving 1. What's left then is the minus 1 that we factored out, along with the x minus 10 factor in the numerator, and the factor of x minus 7 was the only remaining factor after simplifying for our final simplification of that multiplication problem.